Hi guys, so this is going to be a short lesson talking about correlation in line of best fit. So what you see down below your notes is what is correlation. So that word correlation is referring to, I'm going to write this down in our notes, it's a measure of relationship or of a relationship between two variables. Let's see, I might not be able to see that. So there we go. A measure of relationship between two variables. So then you see types of correlation, and they give you a bunch of scatter plots here, right? And they're just showing you the different types of relationships that we have. Okay, so our first one, you notice how as our x-axis is increasing, our y-axis is also increasing, right? So for example, this could be like as age increases, our weight also increases, right? Or as our age increases, our height also increases. Now it says moderate positive under there. I want to cross out that word moderate. Let's just refer to it as a weak positive. So this would technically be a positive correlation here because my dots are going up, right? As my x is going up, my y is also increasing. Okay, but it's called a weak positive because the points are not that close together. Okay, if you look at the strong positives, see how they're a lot more closer together? All right, so we call that specific relationship a strong positive correlation. Okay, and then my perfect positive correlation is when my lines are in an exact perfect line there, just like that. Okay, and then you also have the same with negative. So you can have a weak negative, you can have a strong negative, and a perfect negative correlation as well. They just give you a weak negative in this example, and then they have no correlation. So there's absolutely no relationship between your independent variable and dependent variable. Okay, you can also have a relationship that's a nonlinear correlation. So you guys should see that's kind of like that U shape, or so maybe like a quadratic or a parabola. So that could be a quadratic sort of relationship that we have going on there. Okay, and down below, it's just showing you guys the main ones that you'll be seeing is either a positive correlation, a negative correlation, or no correlation. And notice that I drew a line through those positive and negative correlations. We're going to be talking about line of best fit in just a minute, just to kind of represent that relationship that's going on. Okay, so if you go to the next page, so I'm going to flip. Okay, and it should give you a graph comparing the temperature in degrees and then the sales. Okay, doesn't really give us much more information than that, but just we're comparing temperature and sales of money here. So our first question is, based on the scatter plot and line of best fit, what is the predicted sales when the temperature is 14 degrees? So one thing we need to talk about here is this line of best fit, right? So I'm just going to go ahead and draw a little arrow. I'm going to write line of best fit. Okay. And what you want to think of the line of best fit as, it's kind of just like a line that we form that we're trying to hit as many points as possible to make it represent that relationship. Okay. Now, whenever we have a scatter plot, that line of best fit, we're going to refer to that as the prediction line. So I'm going to write in like little quotation marks here, prediction line, because it's predicting the trend of our data here, right? We have the actual data points, those black dots, and then that line, that trend line is kind of just representing the general pattern that we have. Okay, so back to our question, based on the scatter plot and line of best fit, what is the predicted sales when the temperature is 14 degrees Celsius? So if I go to 14 degrees Celsius here, and I go up and I see where exactly on my line that's representing, and I go over, it looks like it's right in between 200 and 300, right? So we can approximate that to about $250. Just like that, okay? And then our next question is, based on the scatter plot and line of best fit, what is the predicted sales when the temperature is 20 degrees Celsius? So if I go to 20 degrees Celsius on my graph here, oop, that's 22. Sorry, if I go to 20 degrees, I go all the way up to my line, and my line is right here at 20 degrees, and it looks like that's at about $450. Okay, so that's just using our line of best fit to predict some data here, all right? Now, if you flip over to the next page, you could pause the video right now if you want to attempt the next scatter plot with the two questions. I recommend you do that. Okay, so you can pause right here, and then you can pick back up when you want to check your answers. Okay, so looking at our scatter plot that we have, it says emails per day by age, and it says that on our y-axis we have the average of emails per day, and then we have our age on our x-axis. Okay, So based on the scatter plot and line of best fit, what is the predicted average of emails per day when someone's age is 12? So if I go to my age 12 here, and I go up and I look where that's hitting my line, that looks like it's at about 30 emails. So I'll write 30 emails. Make sure you use units when giving a solution, okay? And based on the scatter plot and line of best fit given, what is the predicted average of emails per day when someone's age is 36? So I'll go to 36 on my x-axis, go up and see where that's hitting my line. It looks like it's just shy of 20, so maybe 19, we'll say. 19 emails to try and be exact. Okay, so that's how you use your line of best fit to predict some data when prompted with that type of question, okay? Now the bottom, we're gonna actually talk about how we can estimate a line of best fit. We need to review our skill of writing an equation in slope-intercept form. So if you guys remember, this is a pre-algebra skill. Our slope-intercept form is represented as y equals mx plus b, where our m value is our slope, or our rise over run, and our b value is our y-intercept. Those are the only two pieces of information you need to form those equations. So if we look at my first example here, the y-intercept is always the easiest thing to pinpoint. So if I go ahead and look, that's crossing my y-axis at 4. So I'm going to write my b value is 4. Now to find my m value, I got to find the rise over run between 2 points. Now we can use our y-intercept as 1 point. Now we want to find another point where my line crosses the edge of a box here. So it looks like I got a nice one right down here, right where that line hits the edges of the square. So if I count my rise over run, looks like I'm going up 1, 2, 3, 4, 5, 6, 7, and I'm running 1, 2, 3, 4. So my slope, or my m value, is just simply 7 over 4, and we'll keep it as a fraction. We don't have to go ahead and simplify or make it a decimal. So simply my equation is y equals, instead of m, I'm going to replace the m with the slope we just calculated, 7/4 x, and then plus b, and we know our b is 4. Okay, so I'd give us the equation of our line there. Now notice how with this line here, it was increasing, right? So every time you have a line that's increasing, make sure that that value in front of your x or your m value is in fact positive. So yes, we have a positive 7/4 as our slope here. Now my next one, notice how my line is decreasing. So yes, my m value should definitely be a negative here, okay? And we'll calculate the rise over the run in a second. Let's first identify that y-intercept. So it looks like my y-intercept, my line is crossing my y-axis at a positive 1. So my b value is 1. And then we got to find the rise over run between 2 points. So I'll use my y-intercept as 1 point. And then as my other point, we can use maybe to the edge of the graph right there. So it looks like I'm rising 1, 2, 3, and then I'm running 1, 2, 3, 4, 5. Now technically I'm going backwards in the negative direction, so that's where I'm going to be getting my negative slope from. So it's technically a -5. All right. When I do rise over run, 3 over -5, that's going to result in a negative slope anyway. So my m value should just be -3/5. And again, putting those two concepts together, I have y equals, my m value is -3/5, x plus b, or plus 1. Okay. If you want to pause the video now and try the last one on your own, you can do so. If you just kind of want to follow along for the last one, that's fine too. Okay, so let's see, for my last one, I got an increasing line, so my slope should definitely be positive here. So I'll leave my m value as just blank. And then my y-intercept, or my b value, is crossing right at the origin, which means my y-intercept is going to be 0. Okay, now for my rise over run, I have my 1 point as my y-intercept. Where can I get another nice point? Looks like maybe right here. So if I calculate my rise over run, I'm going up 3 and over 1. So 3 over 1, or just 3. 3 divided by 1 is just 3. We can keep it as 3. Okay. Now putting it together, I got y equals 3x. Now we can just leave it as that, because plus 0 is not going to change the final result of my equation, right? If you want to put a placeholder of 0, you absolutely can. But y equals 3x is sufficient enough. But I'll write or y equals 3x plus 0. Okay. All right. If we now go to the next page, so now it's just being able to identify the equation for our line of best fit. So that's why we just did that skill there to help with this section. So this is approximating the equation for line of best fit. example 1, okay? And they give us some multiple choice options here. Now, what's nice about this, guys, is all we can really do, some strategies to figure these out, is yeah, we can pay attention to the rise over run, but really our y-intercept is what's going to help us out here, and then whether or not our slope is increasing or decreasing. It needs to be positive or negative. So first things first, I notice that this is an increasing line, right? So that means my m value is going to be positive, okay? So if I go look at my option choices, well, option A says my slope is negative, right? That's a -5. That means it can't be option A. Okay, it could be option B because it's a +5. Option C is also negative, right? So I can cross that out. So I've just narrowed down my choices by 50%. Now all I have to see is, okay, well, the difference between B and D is the y-intercept. Is my line starting at a +25 or -25? So let's see. It looks like my graph for my line is starting at +25, so that it can't be D. So option B would be my correct equation for approximating that line of best fit, okay? Again, if you want to pause and use those strategies for example 2, you could do so. Okay. So first things first, let's see. It looks like my line is decreasing, right? So my m value is going to be negative. Now, technically, your x and your constant, right? They're kind of flip-flop. The x doesn't come first, and that's okay. The order doesn't really matter. Let's see. If my m's negative, this is telling me I have a +5 slope here, right? So I want to cross out A. And B is also telling me I have a +5 slope here, so I want to also cross off B. So I have a -5 and a -5 for slopes there, meaning it could be C or D. But now again, let's pay attention to our y-intercept. Our line is starting at +80 on my y-axis. And for C, it's saying that it's starting at -80. So I can cross off C, meaning D would be my correct answer option there. I'm starting at a +80, and then my slope is decreasing by 5 or 5/1. Okay? All right, so what I'm gonna have you guys do right now is just pause, and if you go and look online, there should be an attachment under today's date called Line of Best Fit Practice Worksheet. You can go ahead and work on that, and then when you're done with that worksheet, you can come back to this video, okay? All right, so the last page of this notes here is gonna wrap up our line of best fit, and I'm gonna show you how to actually find the line of best fit using Desmos, make your life a little easier, okay? So at the top it says to investigate. It's kind of a cutout problem. Someone collected data on shoe length in inches and height in inches from 10 adult men. Her data appear in the table and scatter plot below. So we have a data table. The X value is our shoe length here in inches, and then the corresponding Y value, or the height in inches, is listed across, okay? So here's our scatter plot of those values. So these two are representing the exact same data. Number 1 says, is there a relationship between shoe length and height? We can generally say, yeah, it looks like as shoe length is increasing, the height is also increasing, right? Because those points seem to be going in a positive order here. Okay, so we can say, yes, as shoe length is increasing, I'm going to do an up arrow. Height is increasing, okay? And it says, how would you describe the relationship? Do men with longer shoe lengths tend to be taller? And we kind of just described that above, yet, right? So we can just say yes, and then we've already described that relationship, okay? Now under it says, draw a line of best fit to represent this data. So it looks like maybe our line of best fit could be something like that. I try to get a couple of points on that line there. And we're gonna skip over the residual part for now. We're gonna come back to that in a later lesson, okay? And then it says, let's use Desmos to find an exact equation for our line of best fit, okay? So I'm going to switch screens and have a screen record so you guys can see how I do it on Desmos. And actually what I'm gonna do, I can't do that switch right now because I'm already hooked up to my document camera. So I'm gonna end the video now, and then I'll upload a separate smaller video titled Finding Line of Best Fit Using Desmos for you guys.